I'm Bandinopla. I'll give you the breakdown of how I rigged this arachnoid robot. We are building a real-time Three.js locomotion rig. We control its legs procedurally. We'll start with a cube to use as body. We'll focus on one leg, since the rest are just clones. Create a leg handler class that will be in charge of controlling a single leg and position it somewhere that makes sense. Walk along one of its local axis by some distance and cast a ray downwards to get the ground hit position. Update that every frame. Now, the foot shown in blue will be tracked as a world position. We'll update it if the distance between the goal position and the actual position is greater than some threshold distance, in which case the actual position will copy the goal position. Create a ghost position shown in green that will lerp smoothly following the actual foot position shown in blue. On top of that, after the ghost position is lerped, map the progress distance traveled towards the goal to a sine wave function to obtain a nice hill value used to modify the y position. Add a few more legs and notice, they all move at the same time or very similar. We will fix that. We'll create a gate controller class. It is a simple class that keeps track of all the legs and decides, based on a set of rules, which leg is allowed to move and which legs must remain planted at any given time. This phase is done. The ghosts are going to act as IK targets for the legs. Now onto the IK rig phase. Find some cool 3D robot online and open it on your 3D software. Delete all the legs but one, since we'll clone then. Separate each moving part from the model and create an armature that follows the logic of the robot's structure, making sure each bone starts at the pivot point of the robot's leg. Export it and import it into Three.js. For the IK rig, we'll use Garrett Johnson's closed chain inverse kinematic JS module. We'll traverse the bones of our skeleton and create a joint and link pairs. The joints will only be allowed to rotate in the axis that our model was visually designed for, so make sure to respect that. In this case, the first bone can only rotate on its y-axis, while all the others only on their x-axis. Once you have the IK rig set up, on every frame, update the bones of the skeleton to match the positions and rotations of the IK rig. And lastly, feed the IK rig solver, the IK goal provided by the rig we did earlier. Here you will have two handlers working as a team, per leg. One will calculate the IK goal, and the other will delegate the IK logic to the IK library and then read the rig and update the bones to make sure they are in sync. Everything else will be stick to the bones. If you wrap everything into one class, you can easily clone the other legs and you're done. Hope you find it useful.